So we have done this and we have done this. Let's pick out another one. Let's try this h. Okay, so we're going to do h. It says a equal to h a plus b over 2. Okay, so recognize again this formula. It's just an area of a trapezium. Okay, so half of the height, so half of the height between the two parallel lines in a trapezium, multiplied by the sum of the base and the top. Okay, the parallel sides. So most of you would recognize it as half is h over 2 a plus b. Like this. Okay. And the reason we actually have h over 2a plus b here is that a trapezium is essentially two triangles that have a shared height. Okay, so it would be half ah, half bh. Okay, then you're adding. So you want to rescue here, we want to rescue a. So we can do again, get rid of h over 2. We're going to do this in one step. Okay. So we want to get rid of h over 2 in one step. So it's a rescue operation. Our eyes are on a. We want to get a. So 2 over h here. Whatever we do on the left hand side, we have to do on the right hand side. That's how we maintain equality in math. Okay, so here a over a plus b. I'm going to put it on the left hand side. Okay, it's equal to, then here it's 2a over h. Okay, we want a, so a is equal to, we transpose this one to this other side here. So this one was positive. Okay, a number carries, or a number value, it carries the sign to its left. So this one was positive. When it goes there, it actually becomes negative. Okay. And just in passing, because sometimes we have these routines that we actually don't know where they come from sometimes. Okay, so I'm going to show you how that is solved. Don't use this, okay, as in it's very time consuming. You're also adding some seconds to your math, which is very unnecessary. So here what you have is this one is the answer, by the way. We're just trying to explain something. So once you get rid of b is added to a. So to reverse that, we have to subtract b. Okay, so the reverse for addition, it's simply subtraction. So whatever we do on the left hand side, we do on the right hand side. Okay, so you'd get a equal to 2a over h minus b, like this. You can leave it like this, or you can combine it into single fraction, but I advise you not to take that extra step. It's very unnecessary. Okay, this one, it's sufficient the way it is right now. So that's it. So we have done this one, a, we've done this one, and we've done h. Okay, so now we want to look for let's go for a simpler one, and then we go for a much more difficult one. So the simpler one we can go for is let's go for I. So I, it says a equal to v squared over r. Okay, so this is area, velocity squared, centripetal velocity. Okay, so this is centripetal motion. So v squared, the speed, not the centripetal velocity, the speed, or divided by the radius. So the radius from, if you're going in a circle and then there's a certain radius from the equilibrium point, that's the r that they're talking about here, and then v is simply the speed. So this would be the acceleration. Okay, so you want to rescue r here. How do you do it? So in order for you to rescue r here, you can go ahead and then multiply by r both sides. So you'd get ar equal to v squared, like this. Then you divide both sides by a. Okay, we are dividing both sides by a just because a is multiplied. So a is a multiplier to r, so to get rid of a, you have to divide. So whatever you do on the left hand side, you have to do on the right hand side. So you get v squared over a, like this. But this doesn't have to be this way necessarily. There's a way again to actually save time and then just combine these steps. So how do you do it? You say a, which is your acceleration, it's equal to v squared over r here. So this is our alternative, okay, alternative method. Alternatively, this is what you do. So what you do now is you recognize that you want to get r to the top. So the way that you get r to the top is to multiply by r. But then in the same breath, you can actually realize that you want to get rid of A as well. So you can actually do this in a combined step. Okay, so we're getting rid of A from this side, and you're also getting rid of R from this side to put it to the top, to the left hand side. So what you realize is that this one they cancel. Okay, and this one they cancel. So you have done this math in just a single step. R is equal to V squared over A. Okay, so this is how I'll do it if I wanted to really save time, because sometimes you need the time to revise your work. Sometimes you really know what you're doing, but then, human error. Sometimes you make those lousy mistakes. We'll also teach you how to revise your stuff as well. What questions to actually revise, because you don't have to revise all of them. There are some questions that you won't know if you have done wrong in your exam. So we'll actually do a video, separate some videos, a series of videos, just explaining that stuff. But essentially, this is it, and it's really clean. The alternative method uses only one step, so this was really good. Okay, so now we have done this, and we have done this. Okay, and we have done this. So we are only left with one. So we just want to do one here. So let's do this one for summation. It's not actually complicated. So this one is sum of n terms. It's equal to A, which is the first term, minus 1 minus R. So this is geometric series where R is the what can I say? Where R is the factor. Okay, in the geometric progression, that's the factor that's sort of like repeating. You can think of it as the rate. Okay, so to the power n, which is number of terms. Okay, so this is sum of terms in a geometric progression. So 1 minus R like this. So what you do here is you want A, and you can actually pause this video and see if you can do it in one step, because you actually don't have to do it in several steps at all. So the way that you do it is you draw. So why am I writing 2 here? It's supposed to be n. Okay, so let me correct that real quick. And then over 1 minus R like this. Okay, so what you do is you introduce, so multiply by, you want to get rid of these 2 here, because remember, we want to rescue A. So you want to get rid of this 2, you have to get rid of this one first, and you can do this in a single step, or you can just combine them. Get rid of this one and get rid of this one here. So whatever you do on the left hand side, in order for you to remember, this is an equation, this is equal to. So if you have to treat the right hand side by a certain factor, you also have to do the same for the left hand side. Okay, so it'd be 1 minus R to the power n like this. So what you realize now is that these ones, they cancel. So this one and this one, they cancel. This one and this one, they cancel. And then you're just left with A, and it's equal to Sn. So you recognize that Sn here, it's multiplying this whole factor, this whole numerator factor. So the way that I would write it is to say Sn, 1 minus R here, divided by 1 minus R to the power n. And then this one would be my answer. Okay, so Sn 1 minus R, and notice that we did it in just one step. Amazing. This is how you're supposed to be doing it. Okay, so this is great. We did that part, and it's done. And here, just look out, because some people, what they would do is that so this is the wrong way to do it. They'll do exactly this operation, they'll recognize it, and then they'll say Sn here minus R. Okay, so they're just multiplying Sn by A here. 1 minus R to the power n. This wouldn't be wrong. You should realize that the numerators, they're actually multiplying, and then this one, it's just a term of its own, because it's tagged in within a certain fraction. Okay, so this is what you're supposed to look out for. But if you've done this, then that's really incredible. And if you've watched up to this point and you haven't subscribed to our channel yet, I advise you to, and make sure also you like and comment sometimes, because it helps other people like you discover our channel. This was really productive. I really liked the styling in the myth that we're dealing with, and then also realistic. So this has been Habit Tuber, and I'll catch you in the next video. Cheers.